some really nice volume problems. So we're going to do a couple of those, and we're going to get, did you guys like the video I made?
Yes.
Yes, good. Okay. I find that they're handy dandy. We're recording now, so you can always go back and look at this too. So I'm going to share my screen with you. We are officially recording. I am going to share. Here we go. Okay. So starting with this, you'll notice that this says prisms and pyramids. Do you see how it says prisms and pyramids?
Yeah. Yeah.
Okay. First things first is let's identify the prisms. Okay. So if I said to you, is this a prism or a pyramid?
It's a prism.
What kind of a prism is it?
Cylindrical?
Oh, hell no.
Oh.
It's not cylindrical because a cylinder is like made up with, it's like a circle, right? A cylinder.
Yeah.
Yeah, cylinder, you know, it's like this. It's as if I took, if you guys look at me, it's as if I took a piece of paper and I folded it, that rectangle becomes a cylinder, and the bases look like two circles, a circle here and a circle here, okay? So that's not gonna be, so that's a cylinder, but this first one here, if I said to you guys right now, that's 1, I'm gonna call this 2, I'm gonna call that 3, gonna call this 4, gonna call this 5, and I'm gonna call that 6. You guys take a moment to identify what those are. And when I call on you, be prepared to tell me what it is. You'll know that this is a cylinder because your parallel bases are circles. Okay. Okay, so for the first one, just to keep this, here we go. Connor, what's the first one called?
First one?
Yep.
Hexagonal something?
Hexagonal button.
I forget what the last one.
It's right here, you big dope.
Prism.
It's a prism, right? A prism, what makes something a prism is that it has what? Anybody wants to shout that out? Two bases that are? Good, that are parallel, good. All right, now over here, number 2, Harrison, what would you call that?
That would be a square prism.
Yeah, what's another weird name for a square prism? You know what it is, it's easy. Ice blank. Rubik's blank. Anyone?
It's a cube.
It's a cube, very good. So another name for a square prism is called a cube. Number 4, Julia, what do you got for that one?
It's a pentagonal prism.
Pentagonal prism, yep, pentagonal prism. Oh, I skipped number 3. So on number 3, we're gonna go with Emily. What kind of a prism is number 3?
An octagonal prism.
There's 8 sides, looks like there's 8.
Like how would you say like an octagonal prism?
Well, if this is hexagonal, then we can say this is? Octagonal prism, yes. Yeah, it does really tap into our pronunciation skills, doesn't it? I love that. Okay, Sienna, what would you call 5?
A rectangular prism.
So would I. Okay. You guys know this is my 3rd cup of coffee. Do you know what's in here? What's always in my 3rd cup now?
Water?
What did you say?
Water?
No, it's coffee, you big dope.
Well, yeah, it's coffee.
Yeah, but what do I add to my coffee?
Water.
Well, you have to make it with water, but
Oh, yeah.
it's not,
Sugar and milk.
not black coffee. I add something special to it in my 3rd cup of coffee.
Red Bull.
Huh? Yeah, that, yeah, right, Red Bull. No, chocolate milk.
Wait, really?
It's
Oh,
a,
Is that
it's a
good?
mocha.
that's what they call cafe mocha. Hell, are you kidding me? It's delicious. I usually
Actually,
put
probably isn't that
regular
bad.
milk. I put regular milk in my first 2 cups, and then the 3rd cup is the mocha. It's delicious.
Who said Red Bull?
I think Nick did.
That was me.
I think
God bless you.
I'm gonna say Nick, I'm gonna say Canyon's
No,
response.
that was Connor, but I was gonna say Monster. So
All right. So what kind of a what is this guy called here? Rotella.
Triangular prism.
It's a triangular prism. Good, because your 2 bases are. Thank you. Okay. So we know what those are. All of these other ones here, if I put an X here, an X here, these are all considered what?
Pyramids.
pyramid. Pyramids.
That one, sorry. These are all pyramids. These all fall under the family of pyramids. I'm gonna get crazy. The way you name it is based on what their on what the base is. And notice that all pyramids only have 1 base versus where all prisms have 2 bases. Good. So does somebody want to take a crack at what this one is called here? I'll tell you what. Rachel, what would you call this one? The base looks like it's in the shape of a
Triangle.
the
I mean, a
base
square.
looks like it's in the shape of a square. So therefore this is called a
Cube.
square.
Square.
Well, this is a what? What this falls under what family, sweetheart? We said that these are all considered prisms, but these that I have marked with X's or that I'm actually accidentally deleting, these are all called
Pyramids.
These are all called pyramids, and they're based on, we name them based on the shape of their base. So this one over here, you said is shaped like a,
Square.
so therefore this is called a square.
Pyramid.
Yes, this is called a square pyramid. So what would you call this one?
Triangle pyramid.
Triangular pyramid. This one you would call a?
Uh,
This side. Hexagonal
hexagonal pyramid.
pyramid. Good. All right. Now the difference is, you guys, if you look at a prism, right, you have 2 bases, and the bases are surrounded by what? The bases are surrounded by what shape?
Rectangles.
By a bunch of rectangles, right? These are a bunch of rectangles that are surrounding it. Whereas a pyramid has a base, but then what shape is actually surrounding it where they converge to a tip?
Triangles.
Triangles, exactly. Yes. Okay, so a prism has 2 bases surrounded by rectangles, but a pyramid has a base that's literally surrounded by a bunch of triangles. These are really nice things for you knuckleheads to think about as we go along, okay? But today we're going to focus on just prisms, but I just wanted to introduce you to pyramids because you've seen them your whole lives, right? We've seen them, for goodness sake. So, and then we'll figure out how to find the volumes of those next. But let's say that we want to find the volume of this. What is this shape called? What is this called?
Triangular prism.
This is a triangular prism. So if we want to find it, how do we get the volume of a triangular prism? Actually, how do we get the volume of any prism? How do we find the volume of any prism? Anybody want to take a
You
crack at that?
find, isn't it like the area of the base times the height?
Area of your base, good. Times the height of the prism, yes?
Yep.
The prism is how tall it is. So if you look at this diagram, can you guys tell me how tall this prism is?
12.
It's 12 centimeters, exactly. Because it's as if you took the 2 bases and you stand it on its base. The height of it is 12. So therefore, this is the height of the prism. Yes, that guy is the height of your prism. So now it says the bases are equilateral triangles. So in other words, according to Lucas, we have to find the area of the base and then multiply it times the height of the prism. So we all know that the base is an equilateral triangle. So it's going to be 1/2 base times height. It just in this instance, because I have equilateral triangles. Is everybody okay with that? Hello, is this thing on?
Yep.
Okay. Now the problem is this is an equilateral triangle. So I have to figure out what the area of this triangle is. What do you knuckleheads recommend we do? Always. Well, we can't do SOHCAHTOA yet. The first thing we got to do is split this in half. Yes?
Drop in altitude.
Drop in altitude. Thank you. What does it make these 2 angles right here? This one and this one. It's an equilateral triangle. So what are the measures of all 3
90
angles, everybody?
degrees.
30.
they're all 60 degrees. So these are all 60, 60, 60, right? And then, so that means these are 30, and then this is 60, right? So now we have to figure out, we already have our base, which is how much? What's our base of the triangle, everybody?
4.
The base of the whole triangle, everybody? 4 is 8. Sorry, the whole base is 8. Now we have to go get the height. So why don't you guys go get me the height for this guy? Tell me what the height of this triangle is. And I can actually, while you're doing that, I'm going to draw it right here because this is technically the height of the triangle, right? So, and that's what we're trying to find the area of. And then we're going to multiply that times the actual height of the prism itself. Because remember, when we stand a prism up, it's always smart to stand it on its base so we can see how tall it is. Okay? All right. Let me know what you guys get. Round to the hundredths place. Does anybody have it yet?
$6.93.
6.93 it is. Okay, so the height of this is going to be 6.93. So the volume then is going to be equal to 1/2 times the base, which is 8, times the height of the triangle, right? So that's 6.93 times the height of the prism, which is 12. So your final answer should be times 8. So we should add,
27.
what'd you say?
Isn't it like 27.71?
No,
That's
because
12.
I got
Oh, yeah.
3.55
So 332.5.
yes?
Oh, yeah.
Because
Yeah.
remember, it's 1/2, because remember, this right here is the base of the prism, and this is the height of the prism right here. So the base of the prism is this guy right here, which is your triangle. So it's 1/2 times 8 times 6.93 times how tall the prism is, right? So the height of the prism is how tall it is. And then I got 330, excuse me, 332.55. Did you guys get that too?
Yeah.
What are my units?
Centimeters cubed.
Cubic centimeters? Say it better. Say
Yeah.
cubic centimeters? Okay, great. All right, moving on to the next one. So let's say that we want to find the volume of something like this. First of all, this represents part of a what? This looks like it's a part of a what?
Cylinder.
Looks like it's part of the cylinder. So we know the volume of a cylinder is pi r squared h. How come we know the volume of a cylinder is pi r squared h?
Because that's the area of the circle times the height.
Right, because remember, when we're doing the volume of a prism, right, the volume of a prism, I'm going to say it again, is the area of your base times the height, i.e. how tall the prism is, okay? That's what I like to do. I like to see how tall the prism is. All right, so this right here, and if you look at a cylinder, the cylinder is basically, the base is in the shape of a circle. Is everybody okay with that?
Yep.
If I'm going too fast, slow me down a little bit, okay? So this is the area of our base, right? This is times how tall. That's what the height is, how tall that the prism is, okay? Now, if we look over here, could we just get the full volume of just the whole cylinder without cutting out that piece? What is that, you know that rolled up cake that looks like it was rolled up into like a cylinder and then you slice it down and it's got like that, like it's like, it's devil's food, but then that delicious white cream in the middle. Do you know what I'm talking about?
Yeah.
The swirly thing. Yeah, some of us know what I'm talking about. So let's say instead of cutting it this way, you know, somebody went and said, I'm cutting it that way. I want one giant piece because I'm selfish.
Twinkie.
Like it's not a Twinkie because a Twinkie is not. Yeah, it's not a Twinkie. But I'll look up what this thing is. But anyway, if I said to you guys, can you get me the volume of the whole cylinder? Can you? Can you all get me the volume of how tall is this cylinder, guys? How tall is this cylinder? 35 centimeters. Very good.
35.
Yes, 35, because if you were to stand it upright, if you were to stand it on one of its faces, it's going to look like this, right? So can you guys get me the volume of the whole thing? The volume I'm waiting for you, of the whole cylinder. Let me know what happens when you get the volume of that whole cylinder, okay? And again, it's pi r squared h. And then we'll figure out how much of it got cut out in just a minute. But I'll wait for you guys to do it. All right. And round to the 100th place for me. Let me know what you chuckleheads get. Okay. What's the radius we're using? Sarah, what's the radius we're using, honey?
5.5.
Yes. Do you have the volume, honey?
5.5.
Do you have the volume?
Yeah, I got 3,326.
0.16. Don't forget about that 1.6, right? And it's cubic centimeters. So that's the volume
Yeah.
of the whole cylinder, right? Everybody got that for the volume of the entire thing? Yes? Hello? How would we figure out,
Yes.
how would we figure
Yes.
out
Yep.
how
Yeah.
much of the
Yes.
cylinder we actually want? Does anybody have any ideas? Because we only want a fraction of the cylinder, right? That's what we're looking for, is the fraction of the cylinder. Any suggestions on what we would do? I
You
mean,
multiply it by 310 over 360.
yes. You only want the fraction because you're talking about 310 degrees out of 360 degrees. So the actual volume that we're looking for, we're going to do 310, very nice, divided by 360 times that 3326.16 cubic centimeters. Because that's the fraction of the entire thing that we want. That's the significance of this number right here that we were given, okay? So if we multiply that times 310 divided by 360, we get 2864.19 cubic centimeters. So always take a look at that. So my thing is I like to find the whole volume and then say to myself, 310 divided by 360 is about 86%. So in other words, we're cutting, if 86% is left, how much was cut out? If 86% was left over, how much was actually cut out? Anybody? Well, everything's based on what percent? Everything in life is based on what percent?
100.
100%. So if this is 86%,
100%.
the piece that was cut out represents what percentage of the whole thing? So the 310, this is about 84%.
14%.
You mean 16%? I mean, this is 86, yes, 86%. Yeah, so the piece that was cut out represents 14% of the total cake. Does everybody see that? Because again, everything in life, when I talk about a whole cylinder, that represents 100% of the cylinder. If I cut a piece of it out, I've taken a percentage of that 100 away, and in this case, it was 14%. Okay. We're going to finish up with this guy, and then we're going to call it a day, and then you guys can try out some stuff there. What do you see? It says a volume, the hemisphere is hollowed out of the top. So just imagine that we hollowed out that top part right there, and we want to find out what the volume of this thing is. What does this piece here represent? What does it look like it's part of? This shape right here that we cut out is right.
A sphere.
It looks like it's half of a sphere, doesn't it? Yes? Everybody see that? That it's almost as if you were to put a tennis ball here,
Yeah.
Yes.
right? This is here we go. Oh, we'll go with my cup of coffee. And it's almost as if we were to take a tennis ball or half a tennis ball and put it inside the cup. Does everybody see? Can you all see me as I'm trying to show you? Just kind of look over, if you can scroll over to where I'm at. So I'm taking something here, and I'm putting half a tennis ball in there, right? And I'm trying to find the volume. Now, the important thing is one thing you guys don't know is, what is the volume of a? You don't know the volume of a what?
Sphere.
Thank you. You don't know the volume of a sphere. You don't.
Sphere.
Right, you don't. So the volume of a sphere, Mama Chua is going to give to you. It's 4/3 pi r cubed. Okay? That is what the volume of a sphere is. And what you could do is check this out, is make this look like a little bit of an oval instead of a circle. And then you can go ahead and do your R there. Okay? So the volume of a sphere, like a tennis ball, a bowling ball, a baseball, an orange, a grapefruit, right? Those are all considered spherical. Say spherical with me. Say spherical with me. Thank you. Okay. So the volume of a sphere is
Spherical.
4/3 times pi r cubed. And it's interesting, it's pi r cubed, it's r cubed because how is volume measured? Volume is measured in what kind of units, gang?
Cubic units.
Cubic units. So that's why this is r cubed, because it's measured in cubic units. So for starters, like it's almost as if, like I said, we have this cylinder, but then all of a sudden we hollowed out half of a sphere. So if I want to find the volume, what is the first thing I should probably find the volume of?
Cylinder.
I would find the volume of the cylinder. Good. So we want to get the volume, the actual volume. What do you think we should do? We're going to take the volume of the cylinder, right? And what are we going to do?
Subtract the volume of the sphere.
Subtract, yes, and then subtract the volume of the, it's called a semi-sphere, okay? All right. So I'm going to ask, if your name starts, your last name goes from A through L, go get me the volume of the cylinder. If your last name goes from M through S, you guys are going to get me the volume of the semisphere. So for those of you who are finding the volume of the semisphere, you're just going to find the total volume and simply do what? And simply do what? You guys are sucking the life out of me. You're killing me today. You're killing me. What would you do?
Chop off half of it.
Chop off half of it. Thank you. Okay. So
Chop it in half.
chop it in half, Bivey. Okay.
Yeah, take out, divide by 2.
Divided by 2, i.e. chop it in half. You got it. Okay. Now, the beautiful thing is that this formula, you actually figure out and learn where it comes from when you take calculus. It's very pretty. Okay. So for those of you who have the volume of the cylinder, I'm ready when you are. Remember, volume is equal to pi r squared h. Okay, let's see. Caitlin, what did you get for the volume of the cylinder, honey?
Um, 452.39.
Okay, does everybody agree with that? 452.39 for those of you who are E through L. Good. Then the volume of the semisphere, I am going to reach out to Adriana.
I'm not sure it's right, but I got 268.08.
Okay, so we're gonna do, yeah, so 4/3 times pi, right? Times, what was R4? So 4 to the 3rd power. You use that little caret button, and then you do, so you got what? What did you get, honey?
268.08.
Okay, that represents the volume of a whole sphere, yes? Would you agree that's the volume of the entire sphere? All right, and we only want how much of the sphere? This right here?
Oh, half.
We only want half of it. Just divide your answer by 2, and what do you get, honey?
Oh, 134.04.
Beautiful. Minus 452.39. And we should get our total volume to be 318, forgive me. 318.35 cubic centimeters. Okay, gang? So these are the kinds of things that I'm going to have you guys work on, you know, as we go through. Oops, let me go back here. I'm going to do this. So like if we had something where, I had, you know, this is a cube, okay? I'm just going to put 10 here. And then on top of it, just forgive me if my drawing's not that good. I can't be great at everything. All right. That's supposed to be. Do you know what that's supposed to be? Do you guys know what that's supposed to be if I make it look like that? You guys see, what is that supposed to look like?
Semisphere.
It's supposed to be a semi-sphere. So what I should do is go like this, my friends. I know I'm butchering it. So let's say that there's a semi-sphere on the top of that, right? So, which I could then check this out. So then if I erase this half, you can now see that it does look like a semi-sphere. Does everybody see that? Hello, is this thing on?
Yeah.
My life is being
Yeah.
stripped out of me. So let's say that there's a semi-sphere sitting on top of this little box, and I wanted to get the total volume. Would you all agree that you would find the volume of the cube, because that's a square prism, and then you would just add you would add half a sphere to that to get the total volume? Would you all agree
Yeah.
with that?
Yeah.
This would be 1,000 cubic inches. Where did I get 1,000 cubic inches from? And I'm telling you, my radius here is 3. What is this? Where is this 1,000 cubic inches coming from? If I'm
10
saying
times
my
10
volume.
times 10.
Right, this is the cube, right? Because this is 10 by 10 by 10, because that's what a cube is. And then what the heck is this? What's that?
That's the semisphere.
Hemisphere.
This is the semi-sphere, exactly. So if we were to add those together, that is what we would get, okay? So my advice, my little sweethearts, because again, I assigned some problems for you to work on, but then what I'm gonna do is, I'm gonna stop sharing. But then what I'm gonna do, like I said, is I'm gonna give you knuckleheads some really nice, juicy problems to make videos with, okay? So your job is to make sure that you team up with certain people, whether it's from this class or, you know, from the other class, or combining the two. I don't care what the heck it is that you do, but everything, again, everything but videos are gonna be posted where?
Canvas.
Canvas.
I like
Everything
Google
goes to Canvas. And there's that, you notice I
Okay.
give you that link to upload everything to Canvas with the exception of videos, yes?
Yeah.
All right. I am around for questions later on, and I hope you guys are fantastico. I'm going to stop recording.